Hello, today we're going to be doing a differentiation question. So we have the equation of a curve x to the fifth plus y to the fifth equals 5x squared times y. So A is show that dy over dx is that. Okay. So we just need to derive that original equation. And we're going to need to do implicit differentiation here because it's not just y equals something, it's also like y to the fifth and that. So let's start by the left hand side of the equation is pretty simple. So using the power rule, it's just going to be 5x to the fourth plus 5y to the fourth, but we need to multiply this by dy over dx because we're differentiating with respect to x. So on the right hand side of the equation, we're going to need to use the product rule. So let u be 5x squared and v equal to y. U dash is 10x, v dash is just dy over dx. And so the differentiation is going to be u v dash plus u dash v, which is going to be 5x squared times dy over dx plus 10xy. Okay, and now we need to isolate dy over dx. So let's put all the terms with dy over dx on the left. So 5y to the fourth times dy over dx minus 5x squared dy over dx equals 10xy minus 5x to the fourth. And now let's factor out the dy over dx. And that's going to be 5y to the fourth minus 5x squared equals 10xy minus 5x squared to the fourth. And now let's divide each side by this here. So dy over dx is 10xy minus 5x to the fourth over 5y to the fourth minus 5x squared. And we can simplify the right-hand side even more by dividing each term by 5, I believe. So that is going to be 2xy minus 5 minus x to the fourth over y to the fourth minus x squared. And is this all we can do? Let's see, does this match up? 2xy, yeah, this matches up. Okay, that's good. So that's part A done. Part B, the normal to this curve is parallel to the y-axis at the point x equals h. So this means the tangent at whatever x coordinate is parallel to the x-axis, which means the tangent, we want to solve for the x coordinate when the slope of a tangent is 0 or parallel to the y-axis, the x-axis. Okay, so for part B, dy over dx equals 0. So 2xy minus x to the fourth, this is basically 0. So 2xy equals x to the fourth, and 2y equals x to the third, and y is x to the third over 2. And now we can just substitute this in the original function, isolate x to the third over 2 to the fifth. Okay. And now let's isolate x to the fifth plus x to the 15th over 32 equals 5x squared. Or we can just multiply this out, so 5x to the fifth over 2. Okay, and now we can divide each term by x to the fifth, so it's going to be 1 plus x to the 10th over 32 equals 1 over 2. And this means let's multiply each term by 32, so 32 plus x to the 10th equals 16, and x to the 10th equals negative 16. And this doesn't make any sense because it shouldn't be negative. Let's see, where did I make a mistake? I forgot this 5, so this should actually be a 5. Okay, which means we still multiply everything by 32, which means this is 5 times 16, which means x to the 10th is 80. 80 minus 32. 80 minus 32, which is 48. And now let's listen to the calculator. And that gives us 1.47 to the third significant figure. That is our final answer. So interpreting this essentially means that when x is 1.47, the normal of that curve is parallel to the y-axis. And yeah, that's our final answer. Thank you.